Similarity and right triangle trig, abbreviation for trigonometry. Essential question. What is always congruent and what is always proportional when given two similar figures? Just as a reminder, I will not be here on Monday. I will be at Utah State with some students for a math contest. So you don't, it's an 8A anyway, you won't have me. But on Thursday, I'll also be gone. The next couple weeks is really crazy for me. So on Thursday, we'll also be gone, which is a B day. You will be having a test review that day via video. I will record myself, and you watch the video. I promise you, every single thing that's on the video will be on the test. Yeah, that's how your reviews always are. Okay, and I just found out I have also be gone the following Tuesday for a field trip to Weber State, which ends up being, oh, that's an 8A. So that works out okay. Okay, so it won't affect your test. I was afraid it would affect tests. But your test will be on St. Patrick's Day, okay, on the 17th for the B day. 8A's is on the Friday before. You guys are on the 17th. So next week, review on Thursday. The test will be the following Monday for B day. All right, I'm going to draw a bunch of figures, and I would like you to name the angle relationships as a review. Draw and name each set of angles. Okay, number 1 looks like this. And we're given these little arrows, so you should know what those little arrows mean. Draw that and see if you can recall the name we've talked about for angles 1 and 2, their relationship. There will be 6 total, so draw all the figures, please. The last one. Okay, but raise a hand. First of all, let's discuss what do these little red markings mean on number 1. It means the lines are parallel. That's important because we went through all these parallel postulates when we had 2 parallel lines cut by a transversal. So you have to know that those are parallel in order to use those names. So here I have, inside the parallel lines, I have top left and bottom right. What are those called? What's their relationship? Torrance? Thank you. Alternate interior. Top left, bottom right, they're opposites. Right? So that word is alternate. So the abbreviation is AIA, called alternate interior angles. And what do we know about these 2 angles besides their name? They are congruent. So alternate interior angles are congruent. Okay, raise your hand if you know the name for the relationship on number 2. Number 2. Two intersecting lines. They're opposite angles. Lucas? Vertical, which are, what do we know about vertical angles? They are congruent. But yes, they do cross each other. So these are vertical angles, which are congruent. So the congruent symbol is equal with a squiggly tilde. Okay, Olivia, do you know number 3? Yeah, because they form a line, right? And so it would also be correct to say linear pair. So it can go either way. We know supplementary angles, are they congruent? Are supplementary angles congruent? They could be if both were 90. But what do we know about supplementary angles? Jaren? Thank you. Their sum equals 180 degrees. So number 4, I see those red parallel markings again. So I know these two very poorly drawn lines are parallel. 1 and 2 have a name. This is my favorite one. 1 and 2 have a name. You guys have both already answered things today, so I'm going to let someone else figure it out, but thank you. So this is my favorite one because it's very secret. Secretive. Like the FBI. CIA! What does CIA stand for? There you go. Consecutive interior angles. What do we know about consecutive interior angles other than the fact that these neighbors can be neighbors next... Oh, that's not what I wanted. Neighbors like this or neighbors across the street. What do we know about those types of angles? Jonathan, what do we know about CIA angles? Yes, they are supplementary. They could be congruent if both were 90 degrees, but it's not necessarily going to be the case all the time. So they are supplementary. Ooh, bad writing. Okay. Supplementary. All right, almost done. Number 5. You should notice a box in the corner. Isaac, what are these types of angles called when we have 2 angles in that box? What does that little square mean? 90 degrees. So these 2 angles add up to 90?
Oh, it's complementary.
There you go. Complementary angles. Complementary angles. So their sum is not 180. Their sum equals 90 degrees. Okay, and the last one, Annabelle. I have written here a triangle, and then I have measure of angle A plus measure of angle B plus measure of angle C equals 180. This isn't an angle, well, it is an angle relationship. It's actually a theorem that we've learned about angles of a triangle. This is kind of a mean one for me to just call in one person. Does anyone know the title of this? Mara? There we go. Triangle, angle, sum, because we add them all. So it's called triangle, angle, sum theorem. Theorem, abbreviation, THRM. Okay, so today we're moving on to similarity. You should have a purple pamphlet such as this. If you don't have it, well, then these notes are your notes. Remember we did 2 foldables on one day. We did the yellow one for congruency postulates, and then we just folded this purple one. So if you have it, please pull it out. We need it. the definition, the basic definition of similarity, like when we did dilations or your pupil, remember we talked about how when you go to the eye doctor, your eyes are dilated? And what happens to your pupil? It gets bigger. Does it stay the same shape or does it change to like a star or a heart or a teddy bear shape? It's still a circle. But they are similar. Okay, similarity happens when we have two figures are similar if they are the same type of shape, I'm getting ahead of myself, okay. Two figures are similar if they are the same, I'm going to put in parentheses type of shape, but not necessarily the same size. But not necessarily the same size, period. Two figures are similar if they are the same type of shape, but not necessarily the same size. Also, when we did our dilations worksheet, if you remember when you brought it back to class, we then passed out protractors and we measured the angles of the original and the angles of the new. What relationship did the angles have from the original to the dilated, which was enlarged? Do you remember on your homework on the dilations worksheet? And we passed out your protractors, which are these little things. Looks like this. We did it all together in class. Like the original had 60, 60, 60 were the angles, and then we enlarged it. And what were the angles of the large one? 60, 60, 60. So what happened to the angles? They stayed the same, so they were congruent, right? But did the side length stay the same? No. So in similarity, we have corresponding angles are congruent. Oh my goodness. I'm saying congruent and trying to write corresponding. Okay. Corresponding angles are congruent and corresponding sides are not necessarily congruent but proportional. And we did proportions at the very beginning of class today. And corresponding sides are proportional. Okay, example 1. I'm going to draw two figures, and I'd like you to determine, based off the definition, if these are similar. Are these similar? Okay, draw them and then decide, based off the definition, are these two figures similar? Oh, it's already grouped, okay. So, thumbs up, they're similar, thumbs down, they're not. Thumbs up, they're similar, or thumbs down, they're not. Pick a side. Thumbs up, they're similar, thumbs down, they're not. Similarity would mean that they're the same type of shape, but not necessarily the same size. Corresponding angles have to be congruent, and corresponding sides are proportional. Okay, I'm getting mixed reviews. Well, let's see. Let's talk about angles first. Are corresponding angles congruent? What do these boxes mean? 90. So what shape is this? Square, because you can see all the sides are also congruent, yeah? Over here, I have 90-degree angles, so the angles are congruent. So far, so good. Now the question, I'm going to just double copy this. If I drag this corner out, am I ever going to, because this is called dilation, am I ever going to dilate it so that it would match the other one? The one on the right. Will it ever match this one? Why not? What shape is this that I'm changing right now? This is a square versus what shape is this? A rectangle. But are squares technically rectangles? Are all rectangles squares? No. Squares are rectangles, but not all rectangles are squares. So proportions doesn't work here. These are not similar. Because no matter how you dilate it, it would never form a rectangle because the angles check off, but it fails on the proportion side. Because if this was a square, if I just throw in numbers, they'd all be the same, yeah? So if this looks about the same length, so if that's 4, and they were proportional, it would be a 1-to-1 proportion. But is this side length also 4? No, it's going to be longer, so it doesn't work. Because when I was dragging this corner and trying to enlarge it, it would never form a rectangle. It's like that little game little 2- and 3-year-olds play, where they have that plastic ball with shapes cut out, and they try to stuff the yellow shape inside. And they're trying to like stuff a square inside of a star. It doesn't work. That's why we have the word same type of shape. Because squares and rectangles, they could be the same type if they are both squares. Okay, here's another one. Are these similar? If I gave this 4, 5, 3, and this one 3, 6, 7, are they similar? The key is, are they the same type of shape? I see they're both triangles, but are they the same type of triangle? No. So our answer is no. They have to be the same type of triangle. This one's a right triangle on the left. The one on the right is a scalene triangle. That's an acute triangle. Okay, so now we're going to use proportions to actually solve the sides to make sure they are in fact proportional. Example 2. For each pair, and there's some like this on your homework, each pair determine if they are similar using proportions. Proportions. For each pair, determine if they are similar using proportions. No, let me get head on so I can draw a straight line here. Using proportions, let's check and see if they are similar. The first thing is, are they the same shape? They're both triangles. Now next thing, are they the same type of shape? They certainly look like it, right? So now we're going to set up a proportion. Order is important in proportions, just like ratios. Proportions are 2 equal ratios. So I have essentially a big triangle and a small triangle. So if I set up proportions, or I could set up ratios and just make sure they simplify, 8 and 4 both correspond to the same position, correct? They're both the height. So big over small, 8 divided by 4, what is that? 2. But we have to check the whole triangle to make sure it holds out. If I take the base here, 6 is from the big. What's the base from the small? 3. So let's make sure. Is 6 divided by 3 actually 2? Yes. Let's try one more. We have to make sure it holds true all the way across. 10. Don't say always do it in order. Big first, small second. 10 corresponds to what side? 5. Is 10 divided by 5 also going to be 2? Yes. So are these two triangles proportional since their sides are all proportional? Yes. So that brings us to the 3 theorems or postulates of similarity that's in your pamphlet. There are 3 of them. If you have your purple similarity pamphlet, please open it. If you don't have them, now's the time to write them. Well, everyone should write them anyway. 3 similarity postulates of triangles. Postulates of triangles. The one we just used was side, 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 because we found all 3 sides were proportional. If you remember, congruence also had a side, side, side. 2 triangles are congruent if all 3 sides are congruent. In similarity, 2 triangles are congruent or if all 3 sides are not congruent necessarily, but proportional. So all 3 sides are proportional. The key with similarity is knowing what is proportional and what is congruent. Okay, someone with the pamphlet. What's another one on the pamphlet besides side, side, side? Yeah, side, angle, side. Side, angle, side. There's a paragraph on your pamphlet. Who has the pamphlet and can read the paragraph for me? We're looking for keywords. What does side, angle, side mean in similarity? Okay, Zach? Yep. Okay, listen carefully what he says about sides and angles, please.
2 sides of a triangle are proportional to 2 corresponding sides of another triangle, and the corresponding included angles are congruent, and 2 angles are.
Whew, okay, it's a mouthful. It says 2 corresponding pairs of sides have to be, what's the key word? 2 sides of a triangle are, start with a P, proportional. So not necessarily congruent. So 2 sides are proportional, and the included angle, included is huge. Notice where the A is. It's sandwiched. The included angle is, what's the key word? Is the included angle proportional or congruent? Congruent, because remember, angles are congruent. It's the sides that are proportional. The sides have been dilated larger or smaller, but the angles stay congruent. And there's one more to wrap up the end of our notes. One more. Not angle, side. No. No, we've done side, 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 and side, angle, side. It's 2 letters. Angle, angle. Which technically, if 2 angles are congruent, pairs of angles are congruent, the third is also. So you can even say angle, angle, angle. So, we already talked about this one. 2 angles are congruent. Let's put if. If 2 angles are congruent, then the triangles are, what's the symbol for similar? What's the symbol for similar? It's on your pamphlet. It's similar to the congruent sign. It's only half of the congruent sign. Equal means equal. Yeah, it's the tilde. So this marking right here is what we use for similar. Okay, so your homework is a worksheet which begins by solving proportions. And we practiced at the beginning of class. Then, using some graphs that are here, you look at them and determine side lengths. Make sure the side lengths are actually proportional. And then it gives you the side lengths, and using ratios, you determine if they're similar. All right, let's stop this.